Friends, good morning to everyone. Today's subject of discussion is the synthesis of theophylline. Theophylline is a drug of choice for the treatment of asthma. Theophylline structure is like this. The basic ring system is the purine ring system. This is 1,3 dimethyl purine. I can cut this molecule this fashion. I'll get N, N dimethylurea as the one of the synthons. I'll break this part where the amino group I can introduce. I can break this part where the carbon group I can introduce, and this part is 3 carbon and 1 nitrogen donor. This is an anti-asthmatic agent and it acts by inhibiting adenosine receptors. That's why they come under the classes of adenosine receptor antagonists. As we know, we have to construct the pyrimidine ring, as we have seen in Trop's purine synthesis, where he took urea, and here this is N, N, the methyl group is attached to nitrogen. That's why I will be taking N, N dimethylurea, and here 1, 2, 3 carbon and 1 nitrogen. 1, 2, 3 carbon and 1 nitrogen over here. This part I have taken alpha ethyl ester of acetamide. The alpha ethyl ester of acetamide reacts with N, N dimethylurea. The lone pair of electrons on the nitrogen of this dimethylurea attacks on the carbonyl carbon over here, and ethoxy group get kicked off. The lone pair of electrons on the nitrogen attacks on the carbonyl carbon, another one, and these pi electrons moves onto the oxygen and it becomes O minus, and that combines with H plus from the reaction medium, and this ethoxy group leaves us as ethanol, and I will get corresponding cyclized derivative. This undergo dehydration. The carbon hydrogen bond breaks and this electrons moves towards this carbon. A double bond is formed over here and it has to maintain its straight valency. That's why this carbon kicks off OH minus. OH minus and H plus loses as water molecule and it gives rise to N, N dimethyl pyrimidine 2,4-dione 6-amine. Here I have to introduce the amino group. To introduce amino group, I cannot introduce directly amino group. That's why I have to go for nitration, where I treat with nitric acid and sulfuric acid. The nitration of the carbon occurs to give corresponding 5-nitro derivative of this pyrimidine ring. And this nitro group attached to the pyrimidine ring can be reduced by treating with iron and HCl. And the nitro group gets converted into amino, and that's why I have got introduced amino group at the 5th position. I have to introduce one carbon, and that carbon should be bonded with both the nitrogen. I can construct the imidazole ring system. I take formic acid as we have taken in Trop's purine synthesis. The lone pair of the electrons on the nitrogen attacks on the carbonyl carbon and OH gets kicked off. When you heat it very strongly, dehydration occurs. I'll get corresponding formamide derivative. The formamide derivative which is formed again reacts. The lone pair of electrons in the nitrogen attacks on the carbonyl carbon and the pi electrons on the oxygen moves onto the oxygen and it becomes OH. This undergo dehydration. Once the dehydration occurs, the nitrogen-hydrogen bond breaks and these electrons are shared with the adjacent carbon and it has to maintain state of valency. OH gets kicked off, OH minus and H plus loses as water molecule and it gives rise to corresponding imidazolopyrimidine derivative, that is theophylline. This is how the theophylline ring is constructed. And next class we can deal with the other drug containing the heterocyclic molecule. Till then, have a nice day. Thank you.